On May 11, 2025, China celebrated a groundbreaking achievement in transportation as its magnetic levitation Maglev train reached an astonishing speed of 620 miles per hour mph, outpacing most commercial aircraft. This remarkable feat not only showcases China's advancements in high-speed rail technology but also positions the nation as a front-runner in the global race for ultra-fast transportation solutions. Technological innovation. The Maglev train employs high-temperature superconducting HTS technology, which allows it to levitate above the tracks, eliminating friction and enabling unprecedented speeds. Unlike traditional trains that rely on wheels and tracks, Maglev trains utilize powerful magnetic forces to lift and propel the train forward. This innovative engineering results in a smoother ride and significantly less wear and tear on the train and tracks. Originally developed in Germany, the Maglev technology faced controversies during its transfer to China, including allegations of intellectual property theft during testing phases. Despite these controversies, China's commitment to refining and advancing Maglev technology has led to significant breakthroughs. Speed comparison and use cases. The speed of 620 miles per hour means that travel times across major routes in China could be drastically reduced. For instance, the journey from Beijing to Shanghai, currently taking about 5.5 hours on conventional high-speed rail, could be completed in just 2.5 hours using the new Maglev system. This speed presents a compelling alternative to air travel, especially for domestic routes where delays and inconveniences often plague passengers. Geopolitical context. The achievement reflects China's growing dominance in high-speed rail technology and highlights the contrast with the United States, which has struggled to establish its own high-speed rail systems. While American projects are often mired in bureaucratic delays and funding challenges, China is rapidly advancing its transportation infrastructure, signaling a shift in global capabilities. This development raises questions about the future of transport innovation and infrastructure development in various countries. Environmental benefits. Beyond the impressive speeds, Maglev trains also represent a more sustainable mode of transportation. With reduced friction comes lower energy consumption and diminished emissions compared to traditional transportation methods. This aligns with global sustainability goals and positions Maglev technology as a critical player in the future of eco-friendly transport. Public perception and infrastructure development. The successful testing of the Maglev train has captured significant public attention and admiration, reflecting China's strategic move to highlight its technological prowess. The new system has the potential to reshape urban connectivity, creating regional megahubs and redefining economic dynamics across the nation. Differences between sources. Various media sources have reported on China's Maglev train achievement, each focusing on different aspects. Some outlets emphasize the technical innovations and historical context, while others stress the geopolitical implications and economic advantages over American infrastructure. For instance, one source highlighted the technology's roots in Germany and the associated intellectual property concerns, while another focused on the stark contrast between China's rapid advancements and the slow progress of high-speed rail in the U.S. Timeline of events. 1. Development phase. The Maglev technology was initially developed in Germany and transferred to China, sparking discussions about intellectual property rights and technological exchange. 2. Testing phase. The HTS Maglev train prototype was unveiled and tested in Shanghai province, achieving speeds of 620 miles per hour in May 2025. 3. Future projections. As China continues to refine its Maglev technology, the country aims to enhance the efficiency of its transportation network and further reduce travel times. Standing in stark contrast to the current state of American rail infrastructure. Conclusion. China's achievement with its Maglev train reaching speeds of 620 miles per hour marks a significant milestone in transportation technology and a clear indicator of the ongoing competition in global infrastructure development. As the world watches, this advancement not only exemplifies technological innovation but also has profound implications for sustainability, economic growth, and geopolitical positioning. The future of transportation is being redefined, and China is leading the charge at unprecedented speeds, challenging other nations to keep pace. China's Maglev train, reaching a speed of 620 miles per hour mph, presents several counterintuitive insights that challenge conventional wisdom about transportation technology and geopolitics. Here's an exploration of these points. 1. Speed versus convenience. While faster travel typically suggests convenience, the Maglev train's speed may not automatically translate to user-friendly travel experiences. For instance, passengers still require time to board and alight from the train, and high speeds could necessitate new safety protocols. The notion that faster is better doesn't account for the entire travel experience, which includes waiting times, transfers, and potential delays, issues that may not be as prevalent in air travel. 2. Environmental impact. Although the Maglev train is touted as a more sustainable option due to reduced friction and lower energy consumption, the reality could be more complex. The environmental benefits depend on the source of electricity used to power the trains. If powered by coal or other fossil fuels, the overall carbon footprint could still be significant. This challenges the assumption that high-speed rail is an inherently green solution without considering the energy mix involved. 3. Geopolitical implications. China's advancements in Maglev technology present a paradox in global dynamics. While the achievement positions China as a leader in high-speed rail, it also highlights the weaknesses of other nations, particularly the US. The expectation that technological superiority will naturally translate to geopolitical power overlooks the nuanced interplay of economics, infrastructure investment, and public policy. Countries like Japan and some European nations also possess advanced rail technologies, complicating the narrative of a singular winner in high-speed rail. For economic disruption, the Maglev train's capability to drastically reduce travel time could threaten existing economic ecosystems, particularly in cities that rely heavily on airports for connectivity and tourism. This shift raises questions about how urban centers that are not positioned along the new routes will adapt or compete. The assumption that faster travel will benefit all areas may ignore the potential for economic disparity between regions with and without access to the new technology. 5. Public perception and acceptance. The celebratory tone surrounding the Maglev train's achievement contrasts with the skepticism often directed toward new technologies. While the public may be dazzled by speed, there are also concerns about safety, reliability, and the costs associated with developing such infrastructure. Historically rapid technological advancements have faced resistance from communities wary of change or disruption, suggesting that the acceptance of the Maglev train might not be as straightforward as anticipated. 6. Cultural narratives. The narrative framing China's Maglev train as a definitive leap forward in transportation technology may inadvertently reinforce cultural stereotypes about American innovation stagnation. This perspective risks oversimplifying the complexities involved in infrastructure development and the variety of factors that influence technological progress. It may also fuel a sense of competition that overshadows collaboration possibilities between nations. 7. Investment versus innovation. There's an assumption that financial investment directly correlates to innovation success. China's rapid advancements in Maglev technology may suggest that substantial investments lead to breakthroughs. However, this overlooks the importance of a supportive regulatory environment, public acceptance, and the role of cultural factors in fostering innovation. Countries with less financial backing might still achieve significant technological advancements through different means, such as grassroots movements or alternative funding models. 8. Maglev versus traditional rail. The leap from traditional rail systems to Maglev technology is often presented as an outright replacement, but this perspective ignores the potential coexistence of both systems. Many regions may not have the infrastructure or economic justification to fully transition to Maglev, leading to a hybrid approach that utilizes both technologies. The assumption that maglev is the only future for rail transport may not hold true in every context. 9. Global standards and influence. The notion that China's maglev train sets a new global standard for high-speed rail does not account for the existing technologies and systems in other countries. For example, Japan's Shinkansen and Europe's high-speed trains have established benchmarks that are not easily surpassed. The idea that a single technology defines the future of rail can obscure the diversity of solutions available worldwide. 10. Long-term viability. Finally, the excitement around achieving 620 miles per hour may overshadow questions about the long-term viability and sustainability of such speeds. High operational speeds might lead to increased wear and maintenance costs, and the long-term economic feasibility of maintaining such a network remains uncertain. The assumption that faster speeds will be perpetually beneficial neglects the realities of infrastructure upkeep and technological evolution. In summary, China's Maglev Train achievement opens up a dialogue that goes beyond mere speed metrics, inviting scrutiny of the broader implications for society, economy, and geopolitics. These counterintuitive insights challenge prevailing assumptions regarding technology sustainability and the future of transportation. One of the most significant but often overlooked aspects of China's recent achievement with its maglev train reaching a speed of 620 miles per hour mph is the broader impact this technology has on global transportation dynamics and environmental sustainability. While many discussions may focus on the sheer speed and technological innovation, there are deeper implications that deserve attention. 1. Transformational potential for urban development. The introduction of ultra-high-speed maglev trains can fundamentally reshape urban landscapes. The ability to travel from Beijing to Shanghai in just 2.5 hours compared to the current 5.5 hours by conventional rail has the potential to decentralize populations and economic activities. Cities could emerge as regional hubs connected by high-speed transport rather than being limited to current metropolitan boundaries. This could lead to a significant reduction in urban congestion as more people opt for nearby cities for work, leisure, or tourism. The long-term significance of this transformation is often underestimated in discussions centered on speed alone. As urban geography evolves, so too do economic opportunities, property values, and the overall quality of life for residents. This aspect of transportation infrastructure development is crucial for planners and policymakers who aim to leverage such advancements for sustainable urban growth. 2. Geopolitical ramifications. China's advancements in maglev technology also have significant geopolitical implications that are frequently glossed over. The achievement serves as a demonstration of China's technological capabilities and infrastructural ambitions, positioning it as a leader in high-speed rail technology. This is particularly noteworthy against the backdrop of the U.S., which has struggled to develop its own high-speed rail infrastructure. The competition in transportation technology is not merely a race for speed, it also reflects broader economic and strategic interests. Countries that lead in transportation technology often enhance their global standing and influence. As China continues to innovate and implement advanced transportation solutions, it could solidify its role as a global leader, impacting international trade routes and economic partnerships. 3. Sustainability and environmental impact. Another critical aspect that may be overlooked is the environmental benefits associated with maglev technology. The reduction in friction not only allows for higher speeds but also translates to lower energy consumption and fewer emissions compared to traditional modes of transport. This aligns with global sustainability goals and highlights the potential of maglev systems as a cleaner alternative to air travel and conventional rail systems. The significance of this point extends beyond transportation. It contributes to the discourse on climate change and sustainable development. As countries grapple with the pressing need to reduce carbon footprints, advancements in maglev technology could serve as a benchmark for sustainable transportation solutions. The ability to provide rapid transit options while minimizing environmental impact represents a crucial stride towards achieving global climate objectives. 4. Public perception and innovation culture. The successful testing of China's Maglev train is also a reflection of public perception regarding technological innovation. The enthusiasm surrounding such technological advancements can foster a culture of innovation within a society. When a nation showcases its capabilities in high-tech projects such as Maglev systems, it can inspire future generations to pursue careers in engineering, technology, and sciences. This cultural aspect is significant as it can lead to a virtuous cycle of innovation where increased public interest and investment in STEM fields create a more robust technological ecosystem. In contrast, as the U.S. grapples with bureaucratic hurdles and infrastructure stagnation, it risks fostering public disillusionment about technological progress. 5. Economic impact beyond transportation. The economic implications of high-speed maglev trains extend beyond transportation. By enhancing connectivity, these systems can stimulate economic growth in regions previously isolated by distance. Businesses may find it easier to operate across larger areas, enhancing trade and commerce. Increased accessibility can lead to job creation in both urban centers and smaller towns, fostering economic diversification. Moreover, the infrastructure investments associated with maglev technology can have multiplier effects on local economies, creating jobs not only in transportation but also in construction technology and service sectors. This broader economic impact is often overshadowed by discussions about the technology itself and its immediate benefits. 6. The competitive landscape of transportation technology. The Maglev train's achievement also brings to light the competitive landscape of transportation technology on a global scale. Countries like Japan and Germany have made significant strides in maglev technologies, yet China's rapid advancements may shift the balance of competitive advantage in transportation. The importance of this competition should not be underestimated as nations vie for leadership in emerging technologies. The development of high-speed rail systems can influence global supply chains, tourism, and even military logistics. Thus, the race for high-speed transportation is not solely about passenger convenience, it plays a pivotal role in the geopolitical maneuvering of nations. Conclusion. In summary, while the achievement of China's maglev train reaching 620 miles per hour is a remarkable technological milestone, the implications of this development reach far beyond speed. Understanding the transformational potential for urban development, the geopolitical ramifications, the sustainability benefits, the cultural impact on innovation, the economic effects, and the competitive landscape of transportation technology is crucial. These elements collectively shape not only the future of transportation but also influence global dynamics in ways that are often overlooked in mainstream discussions. As China continues to lead in this arena, the patterns emerging from this technological race may redefine the future of global transportation and connectivity for years to come. 1. Technological innovation in maglev systems. The introduction of high-temperature superconducting HTS maglev technology in China's new train represents a groundbreaking advancement in transportation. Unlike traditional trains which rely on wheels and tracks, the HTS maglev system allows the train to levitate, reducing friction to negligible levels. This not only facilitates unprecedented speeds of 620 miles per hour but also ensures a smoother ride. The roots of this technology trace back to Germany, raising important discussions about intellectual property and technology transfer. This innovation could redefine engineering norms and set new standards for rail transport globally. 2. Impact on travel and infrastructure. The maglev train's operational efficiency has profound implications for travel within China. For example, the journey between Beijing and Shanghai, currently taking approximately 5.5 hours via conventional high-speed rail, could be reduced to just 2.5 hours. This shift presents a significant alternative to air travel, especially for domestic routes, potentially reshaping the travel landscape and encouraging more sustainable transport options. Moreover, the infrastructure built around this technology could lead to the emergence of regional megahubs, fostering economic growth and changing urban dynamics. 3. Geopolitical and economic implications. China's advancements in maglev technology highlight a significant shift in global transportation dynamics, positioning China as a leader in high-speed rail innovation. In contrast, the United States struggles with bureaucratic hurdles and delays in its own high-speed rail projects. This disparity raises concerns about America's competitive edge in transportation and infrastructure development, emphasizing the need for a national conversation on investment in modern transit systems. The maglev train's success serves not only as a technological achievement but also as a geopolitical statement about China's ambitions on the world stage. 4. Environmental sustainability. The environmental advantages of maglev trains are notable, particularly in the context of global sustainability goals. The reduced friction associated with magnetic levitation translates to lower energy consumption and fewer emissions compared to traditional rail and air travel. This positions maglev technology as a viable solution for addressing climate change challenges while enhancing travel efficiency. As nations strive to transition to greener transportation methods, China's maglev system could become a model for future developments in sustainable transport. These 4 points: technological innovation, impact on travel and infrastructure, geopolitical implications, and environmental sustainability, provide a comprehensive framework for understanding the significance of China's maglev train achievement and its potential effects on the future of transportation. 1. The development of the Concorde. The Concorde was a turbojet-powered supersonic passenger airliner that was developed jointly by British and French engineers. First flown in 1969, it was designed to fly at speeds of over 1,350 miles per hour, significantly faster than conventional airliners. The Concorde operated for over 27 years, primarily serving transatlantic routes, and was celebrated for its engineering prowess and luxury travel experience. However, it faced challenges including high operating costs, noise restrictions due to sonic booms, and safety concerns after the tragic crash in 2000, which ultimately led to its retirement in 2003. The Concorde serves as a historical reference point in the realm of aviation technology and speed. 2. The Shinkansen bullet train in Japan. Launched in 1964, the Shinkansen represents one of the earliest successful implementations of high-speed rail. Initially connecting Tokyo and Osaka, it has expanded to cover much of Japan's major cities. The Shinkansen trains can reach speeds of up to 200 miles per hour, offering a reliable and efficient alternative to air travel. The success of the Shinkansen has influenced high-speed rail projects worldwide, showcasing Japan's commitment to punctuality and safety. The system is known for its engineering excellence, with advanced technology that minimizes delays and maximizes passenger comfort, making it a global model for high-speed rail systems. 3. The Eurostar. The Eurostar is a high-speed train service that connects London with Paris and Brussels, operating through the Channel Tunnel. First launched in 1994, Eurostar trains can reach speeds of up to 186 miles per hour, significantly reducing travel time between major European capitals. The service has revolutionized cross-border travel in Europe by providing a fast, comfortable, and environmentally friendly alternative to air travel. Eurostar's success lies not only in its speed but also in its integration with local transport networks, making it easier for passengers to connect to other forms of transport upon arrival. The service has set a benchmark for international high-speed rail travel, emphasizing convenience and efficiency. Future outlook. The impact of China's maglev train achieving 620 miles per hour. The recent achievement of China's maglev train reaching a staggering speed of 620 miles per hour (mph) is not merely a technological feat, it represents a transformative moment in the landscape of global transportation. As we look to the future, several predictions can be made regarding the implications of this advancement for transportation, urban development, the environment, and geopolitical dynamics. 1. Revolutionizing travel efficiency. With the Maglev train drastically reducing travel time, particularly between major urban centers, we can expect a significant shift in travel behavior. For example, the journey from Beijing to Shanghai, which currently takes about 5.5 hours via conventional high-speed rail, could be reduced to just 2.5 hours. This will likely encourage more people to opt for rail travel over air travel for domestic routes, thereby reshaping the aviation market. Future predictions. Increased demand for maglev services could lead to expanded networks across China, connecting more cities and enabling rapid, efficient intercity travel. Global airlines may need to re-evaluate their pricing and scheduling strategies to compete with the speed and convenience of maglev trains, potentially leading to a decline in short-haul flights. 2. Urbanization and economic expansion. The maglev train's capability to connect cities at unprecedented speeds will likely stimulate urban development and economic growth. We can foresee the emergence of new regional megahubs that capitalize on the connectivity provided by these trains. Future predictions. Cities located along maglev routes may experience population surges as people move closer to transit hubs, leading to increased real estate development and infrastructure investment. Economic activities including business operations and tourism could flourish around these hubs, transforming local economies. 3. Sustainability and environmental impact. Maglev technology's inherent efficiency and lower energy consumption present an opportunity for more sustainable transportation solutions. As concerns about climate change and environmental degradation grow, the adoption of eco-friendly transportation will become increasingly crucial. Future predictions. As more countries look to reduce carbon emissions, the success of China's maglev train may prompt other nations to invest in similar technologies, leading to a global trend toward cleaner transportation. We may see a reduction in reliance on fossil fuel-powered vehicles as maglev trains provide a sustainable alternative for both passengers and freight transport. 4. Geopolitical implications. China's advancements in high-speed rail technology underscore its position as a leader in transportation innovation. This development may have significant geopolitical ramifications, particularly in relation to the United States, which has struggled to establish comparable high-speed rail infrastructure. Future predictions. The success of China's maglev train could enhance its soft power, positioning the country as a global leader in technology and infrastructure development, which may sway international partnerships and investments. Countries lagging in transportation infrastructure may seek collaboration with China, leading to increased influence in global affairs as China exports its rail technology and expertise. 5. Technological advancements in rail systems. As China continues to innovate with maglev technology, we can expect further advancements that enhance speed, safety, and passenger experience. The integration of artificial intelligence and smart technologies into rail systems could lead to more efficient operations and improved service delivery. Future predictions. Future maglev systems may incorporate real-time data analytics to optimize scheduling and maintenance, further enhancing reliability and efficiency. Passenger experience could be transformed with amenities that leverage technology such as onboard entertainment systems, Wi-Fi connectivity, and automated services. 6. Challenges and considerations. While the future appears bright for maglev technology and its applications, several challenges may arise. High construction costs, land acquisition issues, and public acceptance will be critical factors in the expansion of maglev networks. Future predictions. Challenges in financing and constructing new maglev lines may lead to public-private partnerships, with governments collaborating with private entities to share the financial burden. As cities grow and demand for space increases, land use conflicts may arise, necessitating innovative solutions to integrate maglev infrastructure into densely populated areas. Conclusion. China's maglev train reaching speeds of 620 miles per hour signifies not just an engineering triumph but also a potential paradigm shift in how we think about transportation. The implications extend far beyond speed, They encompass economic growth, urbanization, environmental sustainability, and geopolitical dynamics. As countries around the world observe China's advancements, we may be on the brink of a new era in high-speed rail transport that redefines connectivity and mobility for generations to come.